Hi guys, so I need to talk you through this lesson because unfortunately it's a confusing one. So what I want you to do is start by copying out this diagram and filling in the boxes with the correct sentence from below. Okay, I'll give you 5 minutes to do that. You'll have to pause me though because I can't sit in silence for 5 minutes. Okay, so hopefully you paused me. I'm going to go through the answers now, and it's cheating if you haven't tried to at least think it through for yourselves. So basically, energy concentrated on the headland should go here. And then it's nice and easy. We've got, as the waves approach the irregular shaped coast, they begin to refract. That should go over here on the right hand side. And then the next one, the base of the wave is slowed by friction, goes above that here as it gets towards the headland. And then longshore currents, which is longshore drift, carry sediment away from the headland towards the bay up here. And then finally, energy is dissipated. That means spread out in the bay, leading to deposition. Okay. So today we are going to be looking at tides and currents with 3 key areas. We're going to look at why they form, high tides, neap tides, and the tidal range, and then oceanic currents from this. So there's some additional information attached and also some tasks for you to carry out throughout this as well. So if you work your way through them, either during, pausing them whenever you need to, or after, but make sure you've got that complete. Okay, so what causes the tides? 3 things. You need the ocean water, you need the moon, which accounts for 2/3 of the pull, the gravitational pull that we're going to be talking about, and then the sun, which is a third. Now we're going to ignore the sun just to start with, and we'll concentrate on the moon, and then we'll bring in the sun later on. So I want you to watch this video to explain what tides are. The lady in it's quite hilarious. Watch her face; she doesn't move at all. So I'll wait whilst you watch that, and then we'll continue. So just press pause on me and load up the link. Okay, the tidal range. So that is just the difference between the high and the low tide. These do change around the world. Mediterranean, for example, has very low range between them, and the UK has a fairly decent one. Now this means we have lots of wave cut platforms, such as this. Wave cut platforms form between the high tide and the low tide, or the high water mark and the low water mark. So we have quite a few of these, whereas around the Mediterranean, they don't. So why does this happen? Okay, so we're going to think about the moon, and we're going to be talking through something called equilibrium theory. So on our planet, there are 2 tidal bulges at the same time. This is why they're roughly every 12 hours, or actually about 12¼ hours, because the moon's slightly moving in the sky as well. And basically, the world is turning in and out of it, okay? So it's not that the bulges move, it's that we move on our 24-hour day as we turn on our axes. So, what happens then? Well, the first bulge is the gravitational bulge, this one here. And basically that is where the moon's gravity pulls the water towards it. Very straightforward. Now, we are spinning round and round and round on our axis, but if most of the water is being pulled towards the moon there, it actually moves our centre of gravity from about there, between the A and the R, to somewhere close to about the H. Now this is really important for the second bulge, which I'm going to talk through now. Oh, excuse Classic FM back in the background. I thought it'd be soothing. So we have something called the centrifugal bulge on the other side. Now, here is the centre of the Earth's mass when the water's being pulled towards the moon. So what I want you to do now is find a bottle of water or a bucket or something and swing it around your head and see if you get wet. If you don't get wet, that's because of centrifugal force or centrifugal effect, and it's the force that spins something that's being rotated to the outside of that. So the same happens to the water. Now you don't need to understand the physics behind this. All you need to know is that because the Earth's mass has moved that way, it spins and it forces another bulge of water to the outside of that circle, of that orbit. So we get another bulge forming here, and that's the centrifugal bulge over on this side. So you can read through this at your own pace, but that's the basics of it. And consequently, we get something that looks a little bit like an eye. It doesn't in real life, it's really, really exaggerated this, but we've got the gravitational bulge, and on this side we've got the centrifugal bulge. So, in a 24-hour period, we basically get 2 highs and 2 lows as we turn in and out of those bulges. But there is some seasonality as well. We get something called spring tides and neap tides. Now, there is absolutely nothing to do with spring tides. They don't happen in the spring. It's random why they're called that. No idea. But watch this video. I'm going to explain it a little bit more. And basically a neap tide is the lowest of the tidal ranges because the sun and the moon are 90 degrees to each other, so their gravities are pulling against each other, whereas, and it kind of makes sense, the moon and the sun being in a line with each other, that means the bulges are going to be exaggerated. They're all working together, so it gets the full force of all that gravity working together. So they've got the biggest tidal range. They call the bulges bigger than normal. Now here's some additional information for like the A's, A stars, so you can read through this at your own pace. There's some keywords in it that would really, really help, taken from another source online. But here is one key point. Amphidromic points. Now, tides actually spin out from about 12 points in our oceans. They actually start there, so there's no tidal ranges at those points. And these are where they are. Here, 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 and so on and so on. So this accounts for different tidal ranges around our planet. So for example, this is why the Mediterranean has absolutely none. It can't really get into there. So it can be quite confusing, but that's all they are. They're the points at which the tides spin out from. And this creates something called macrotidal ranges, which is where it's more than 4 meters. That's what a lot of Britain is. Mesotidal, which is 2 to 4 meters. And then microtidal, meaning mini, where it's less than 2 meters. So you can see those around the world and how different they are. So, you know, northwest Britain, southwest Britain got macrotidal, whereas a lot of the east coast has got mesotidal, and so on and so on. So it does change around. And then we come on to currents. This is fairly straightforward in comparison. Basically, ocean currents are large-scale movements of water in the oceans caused by 3 things: the tides, the wind, and something called thermohaline circulation. Now, if we break this down, this literally means temperature and salt circulation. So it's basically that cold water is denser and also saltier, and the movement of that around. Now, if you go to this website, that will explain it really nice and clearly, and so do the extra information sheets. So I want you to just sort of read through the different types of current and why they happen for me. And then these are the answers to your starting task about the key words. Okay, so hopefully you got all of those right. Any questions, just let me know. I'll be around all day. Bye now.